Hello, this is Łukasz Gandecki from Zolvio, and today I want to talk to you about for loops in JavaScript. From time to time, I still see a for loop in JavaScript codebases. Linters are frequently angry about them, and I would argue that rightly so. There are use cases like async operations that have to happen in order that would be an exception to this rule, and they provide a good excuse to use ESLint disable comment. Nonetheless, in most cases, there is usually a more human-readable way of looping. If you need to iterate over an array, most developers already intuitively reach for map, for each, reduce operations, and so on. But when they want to iterate a number of times, a lot of them still default to using a for loop. So give an example. Let's assume we want to have a function that will create a number of some kind of an object. This might be a part of data initialization or maybe part of a test util. We could define that function like so. Let's first import expect, so you can set some expectations. So we would like to have a function that we say create objects, and if we pass 2, then we want to have an array with objects with increment ID. And then for free, if we pass free, then we would like to have another object like so. So now we can implement it, and we'll first implement it with the for loop for comparison's sake. So usually people would start with creating some kind of an array, then they would create the for loop to iterate. They would set up the edge condition and the increment. Then they would push an object to an array, and at the end they would return the results. So looks like Quokka tells us that this is passing properly. To verify, obviously, we can just change this to free, and then we see that it fails. I'm using Quokka here. This is very similar to Wallaby, but it allows for even quicker prototyping like this one. So at first glance, this seems fine, and this is a construct that developers are very used to seeing, especially the ones that came from lower level languages like C, C++, and so on. But there's a few things here to track and set up. You need to create an empty array that later you need to mutate and return. You need to set up the loop itself, make sure that the increment is done correctly and the edge condition is done correctly. And all in all, the ratio of noise to signal is pretty high. And so to demonstrate this, let's see how we could do this with times function. So if we say create objects times, that will have the same take the same argument here, and then it will take the number and that many times do something with it, and then return all the results as an array. So for that we need to obviously import Lodash here. To see if this works, we can do, I would say, let's do two things. First of all, let's just see that the same test is passing, and to simplify things moving forward, we actually, like, this is our base implementation, and if you want to write a simpler version of a function, if you want to basically refactor things, it's nice to, instead of just redefining the conditions, you can basically compare the results of the two functions. Like you could actually do this in a loop now, say, from 0 to 100, make sure that they all equal. So this code, I would argue, gets straight to the point. The only thing you need to worry about is the logic for what should be the shape and values of the returned objects. Obviously, this is a simplified example, but you can imagine that maybe you would generate some randomized data, or maybe you would create some database on the index. So, for example, like you could imagine doing something like this, that for all even numbers set some value to true. And you might also need to call an external function, or maybe even perform an async operation. You might need to actually create an array and maybe push to it as well. And at that point, you will have to start differentiating between two variables that point to two different arrays. Basically, you have to keep more things in mind in your memory. The amount of code will start increasing at in both setups, but here it will no longer be wrapped with this old school clunky for loop. It will be again better ratio of signal to noise. There will be less things to actively track in your mind. So some people are hesitant using external tools like underscore or Lodash, and they usually worry about increasing the build size. In my opinion, this should be a very rare concern, especially if you are building an application. The maintenance cost should usually be a much bigger concern for you than a few kilobytes here or there. A good example where it might be worth not using any external dependencies are Lambda functions. It's significantly easier to set them up, debug, update if you only use Node.js and AWS SDK APIs. If your function is just tens of lines of code, or sometimes even less than that, it might be a good idea to start with self-contained module. And in that case, you could easily build your own version of times. And just show you an example. So you can say, that we still take the how many as a number, and the second argument we want to have a callback that will return the t result, and in the end we want to let's see, we're getting out of space here. Okay. Obviously, we don't return anything. So we would say, create an array of that many elements. Unfortunately, those elements will be undefined, so map will not iterate over them. So the way to deal with that is we can say fill with 1 or whatever, just a truthy value, and then we map over it, and then instead of running the callback right away, we would actually want to use the index number to then return that. That means now we have an array that goes 0, 1, 2 instead of just having 1, 1, 1. Because when we run the callback, we want to have an array. We want to iterate it over an array with incremented ID or just number. So let's see if that works correctly. So if I say now my times, actually, sorry, we still need to use this. So we would basically recreate this function, but here we would use my times. Let's see if that works. It looks like it's working. And this would be even smaller if you didn't want to use TypeScript, which is probably the case if you are using AWS Lambda and want to skip build and transpile step. So that's how it would look like in pure JavaScript. But still, the decision to not use external dependencies in this case is worth putting under constant evaluation or re-evaluation. Things almost always start small, but then frequently turn much bigger later. Once you start adding more and more handcrafted helpers like this one, or even if you just have a couple but very, very complex ones, consider adding a build and bundle step. And something like our own CDK TypeScript tooling takes care of a lot of the issues that are related to build and bundle steps and updates and debugging. It will also tree shake the code, so your final bundle should not actually increase that much in size. As always, please let me know if you have any questions, and I hope this was helpful. If you find yourself in a need to use a for loop, also please let me know. I will be happy to take a look and see if I could point you to a different direction. Right, thanks so much. Bye.